Hello. Hope you can all hear me okay. Um, Thank you to three of you who have followed. We got Dario 2, Sticky Yellow, Grumpy Dad. Sorry, Old Grumpy Dad, I should say. Thank you very much for following. Right. Um, so I've been working on a video DJ tool. It's off the back of some stuff I was doing at Nova Demo Party. Where I built a Mad Moose DK. Where I built a essentially, if you're familiar with ambi lights, it's basically like backlighting for a monitor. Um, Instead of building it for a monitor, I built it for a stage using DMX lights. So 4 DMX lights, DMX driven lights. Familiar with DMX? I will. There we go. Unfamiliar with DMX? This is DMX. It's essentially RS485, so it's a standardized data sort of communications protocol for doing lighting control and stage effects. So whether it's just regular lighting, LED lighting, or whether it's lasers, whether it's foggers, whether it's bubble machines, if you really want bubble machines, you can control all that stuff over DMX. And in general, they use either 5-pin or 3-pin XLR cables. It's fairly easy to interface with. Yeah, there's an Arduino shield for doing so, which I use the Tinkerkit one. The library for it's pretty good. As you can see, it's fairly cheap. And of course, you can control, I think it's 512 channels off of that. Possibly more, actually. I'm not entirely sure what the limit is. But yeah, 512 channels over that. It's fairly simple. The major sort of restriction there is the backlight I designed was the fact that the demo box sat under the desk where new stuff was being done is not near the stage, so I actually did that over Wi-Fi. So yeah, Wi-Fi control over to that. There was some latency issues initially. I figured it out. It turned out it was my code, not the network. So I can't blame Chris. Yeah, so it's just the essentially all I built was a bridge. Well, in terms of hardware, all I built was a bridge which turned UDP packets into DMX data. So that's all it really did. The smart stuff was all done in software. Now, off the back of that, start thinking more about what if I wanted to control stage lighting, lots of stage lighting. And of course, there's packages out there for doing that kind of thing, but there's quite a lot of learning involved to do that and learning effort. And also, there's various limitations, and you've got to often buy expensive hardware to do the controlling. You've got to buy sometimes you've got to buy the software, and also it doesn't usually come with anything that can display things on the screen at the same time. So you can't really have, well, not from what I saw, apart from with like really expensive packages, you couldn't really do images or videos or like almost like animated GIFs, like repeating or whatever on a screen, and then also sync it with lighting. And also the problem was that the control systems for those, if you wanted them to be like not something that you interfaced with on a screen, but something like, let's say you wanted some sort of physical device in your hands. Usually they were limited to very specific devices. Often they were specific to that hardware and that specific software, which meant that it was like the value add was paying for their hardware, and that becomes quite expensive. So I thought I'd write my own, and I'm at a reasonable state with it at the moment. I'm getting there. So I'm at the point where I can switch back here. Point where I can control DMX devices, and I can take input from a MIDI keypad. In fact, the MIDI keypad that I am using is this thing. It's an Akai APC Mini. The advertising and documentation literally only says it works with Ableton Live, but it's a generic MIDI device. There's no documentation as to how, as to which pads go from, which pads go to which notes, or which of those buttons, or how to read the sliders at the bottom. There's no information out there about that really. Somebody wrote a Python script, but again, it's third party. Somebody had to reverse engineer that. The other thing is that while this shows a lot of nice shiny lit up lights on here, by default it doesn't light up at all, and that's actually the hardest thing to figure out. Essentially, you treat the thing like a MIDI output device, like an instrument, and then you send it note-on commands, and the parameters of the note-on commands will set whether the lights are green, red, or yellow, and whether they're flashing or not. And for the bottom, these bottom pads, you can only get green or green flashing or off, and on the side it's red or red flashing or off. So working out how all that worked was a little bit difficult. Had to do a bit of digging into that. There is some software that claims to monitor MIDI like MIDI events on the system. I just honestly get it working. Tried quite a few of them. Yeah, not much fun. So instead of the other thing I've changed is between the Backlight implementation and this implementation is instead of using this, which is a Node MCU, which is a Wi-Fi ESP8266 based Wi-Fi shield, which obviously was useful in the context of Backlight because of the physical distance between the where the lights were and where the system actually creating the color data was. In this case, it's pretty much going to be a case of you got a cable coming out of the laptop or whatever, and then it goes over to the lighting, so it's much easier. So I've cheated somewhat, made things easier. Initially, I was using Serial. I'll explain a little bit later as to why that was a terrible idea. Now I'm using this, which looks weird. This is a DMX shield on top of an Ethernet shield on top of an Arduino Uno. So again, it's just a bridge between UDP and DMX. The cool thing was that I already had an Ethernet shield hanging around. I had to dig that out. Once I found it, it was good. The great thing about Ethernet, of course, is that there's a bunch of good reasons why you should use Ethernet for things like that. One of them being high data rate. Another one being that you don't get ground loop issues. Because the way that Ethernet works is that it's isolated ports, and also there's very little latency. In fact, that's probably the most important one. But the great thing about me actually already owning one of these Ethernet shields is they're not made anymore, and if you want to buy one, they're really expensive. I think the cheapest I found one was about 40 quid. It's quite a lot of money for just an Ethernet shield. You can buy like cheap, crappy ones, but the reviews for them are very mixed, so you can end up buying like 3 before you find one that reliably works. So it's kind of, I'm not really that fussed on that. So in fact, I can show you the code that's running on this. I'll show you the code that's running on this. I suppose I need to make that a little bit bigger because otherwise you're not going to be able to see that. Let's call it 20. Does that look? Not great. 26. That's much better. Okay, so this is literally just we set up an Ethernet connection. It's just a fixed IP and a gateway and a subnet mask. This Ethernet cable is just going into a USB to Ethernet adapter. That's dead simple. The serial, yeah, this is just for debugging. So we just set up a serial port just so we can. I've got a USB device plugged into that. Sorry, for USB cable plugged into that, I can just monitor it. It just shows up as a serial interface, and I can monitor the debugging stuff. But literally, all this does is in a loop checks to see if there's a new UDP packet. There's a UDP packet. It reads the packet into a buffer. Yeah, there's a packet buffer. And then if the packet size is right, which is 4, which is 1 byte of header, and then a DMX packet, which is only 3 bytes, it's 2 bytes for the channel and 1 byte for the actual data. So it's 0 to 255 for all data in DMX. You can get stuff that does 16-bit data, but in reality, all that's really doing is sending 2 DMX packets, one for, let's say it's channel 40, for a 16-bit data. All it's really doing is setting channel 40 and 41, and in general you'll see them implemented as coarse and fine on the data, so on the implementation. So you've got like a coarse byte and then 255 subdivisions of that, which it may interpret internally as a 16-bit integer, it may not. But yeah, that's literally how that's implemented. So basically, so the packet, so you see on the front, literally the only reason I gave it a header is just in case any spurious data is coming across, because Windows is and other networks are fantastic for just spaffing loads of superfluous UDP traffic around, and then it just decodes the channel data off there and the actual data packet, the actual data for the packet, which is byte, and then I've got some serial data just to show that it's actually working, and then dumps it out to the DMX, and that's it. The hardware. So the bridge itself is dead simple. You can implement it like this. I've got another version that's implemented using a Node MCU for the Wi-Fi. The actual the control, the hardware stuff for my backlight system is almost exactly the same code. It's ever so slightly different, but it's almost the same code. The only improvement I may add in future is being able to pack multiple DMX frames into one packet to avoid the overhead of sending lots and lots of UDP packets. So you could send, say, one UDP packet that contains 10 channels worth of data, and as long as that whole packet is within the max transmission size, the max packet size for UDP, or at least for the buffer for this, it's fine. And then I can just process them all in a sequence and send them out. It's at the moment that's mostly academic, because the bottleneck is absolutely not in the buffer going across the translation between UDP and DMX. It's very, very similar. Very similar. What am I talking about? It's very, very fast. It's much faster than the actual data that I'm sending out, which at the moment is not a lot. I've been hard coding some stuff, but so this is I called the project Theia. It's mostly because I have this thing about naming all of my projects after sort of myths, usually Greek or Norse. I don't know why I do it. Occasionally I name them after StarCraft characters, but usually myths. So this is there, and the reason I picked there is because there brings overtones of extent and brightness. So extensible, and it's about lights. So I thought it fit. It could be nonsense. So yeah. So I figured this stream, as it's the first one, I just sort of give an intro as to what I've built so far, and where I kind of got, and then start working on something that takes my fancy. I've got a few ideas of what I might do. So just to give a quick demonstration of, give a quick demonstration of how this works. So if I just start this up, it's going to be sod's law that something will break now. it works. Okay, so this is the window. I apologise that it's kind of small and that you maybe can't see it that well, but it doesn't matter. All of these just say the word pad because they don't do anything at the moment. So by default, I should also point out that I have this connected. So this is just via USB. This is just a MIDI device. And the project uses a library called, I think it's literally just called MIDI.net, because of course that's what you name your MIDI library for .NET. And all this does is send note messages and I think it's control messages, I think it is, for the sliders. I don't remember exactly. And when you press a pad, it triggers that particular pad in the software, and you can assign actions to a particular pad, or rather, you will be able to. At the moment, the form is blank. What is implemented is all of the back-end stuff, so it can actually process actions for pads and whatever. I just haven't made the actual front-end UI to implement that. I might do that today. I might not. But the bit that you're not seeing at the moment is that there is a folder full of animated GIFs in this application's in this application directory, and they get tiled. Now, at the moment, I'm tiling them on a 4K monitor, so this might look really terrible. Only 1/4 of this would actually be displayed on the real setup. Only because the projector that's likely to be used is 1080p. So just, you know, for nostalgia, we've got the Airwolf logo, and then I've got the button here that says shift on here. Shift button. Oh, it's probably mirrored, so it will say hit instead of shift. But oh well. So every time I press that, it picks the next GIF in the loop. Some of these I found on the net. Some of these I generated from various other videos. I've got quite a few in there. Beavis and Butthead, Bounce by the Ounce. If I have to tell you what that is, I'm going to be very sad. Yeah, can't handle my swag. Some various other geometric ones. Hackers, of course, I've got Hackers. Some Rick and Morty stuff. I pulled these DeadSec ones actually out of the Bink videos for the actual games, because I own both Watch Dogs 1 and 2. They use a custom archive format which somebody wrote a tool for to dump out, and then it's Bink video inside. So I turned the Bink videos into MP4s and then turned them into GIFs. So we've got quite a few nice little DeadSec hacker related GIFs. I particularly like that one. This one goes great with Noisier. So yeah, various bits and mobs. Yeah, more hackers, more ridiculous things. Yeah, Kung Fury. Weird geometric patterns, crazy fast ravey stuff, some movie stuff, cool laser things. I think I found this one on Tumblr somewhere or DeviantArt. Of course, more weird geometric patterns, some really cool 8-bit art. If I can find who made this, I will definitely credit them because I really love this. Pooh Brain, of course, Pooh Brain, Pooh Brain Horse. And who doesn't love the PlayStation boot sequence? Ray raving. My personal favourite clip of all time. Who doesn't love this? Yeah, more. Yeah, I've got a lot in here. Techno biking, weird patterns. I bet this is completely ruining the stream and probably the recording. Yeah, more weird geometric stuff. Windows XP and then back to the start. All right. So that was me just hitting the shift button. The idea is that you can map that shift. The shift button is mapped to a command that cycles the next GIF. I can also hit a single pad and jump to a specific GIF. So fun stuff. Yeah. So yeah, weird GIF stuff, basically. Lots of weird GIF stuff. I'm going to skip back to this so that the stream doesn't look like hell because, yeah, lots of nonsense there. The other thing is that it does actually control DMX lighting. I have that set up. So there are a bunch of classes within the project that describe particular types of lighting. So I've got a bunch of stuff from Equinox and a couple of lasers from Laser World that I've built classes for. Essentially in this, I don't know how well you can see this on the stream. It's probably like really tiny, so I apologize. Essentially on this, you can add new instances of a particular type of lighting and then assign it a base channel. And what it would do is it will validate that all of your lighting doesn't overlap. There isn't an option at the moment to map two devices to the same sets of DMX channels, so that you can control two sets of identical lights with the same channels. I will add that in future. For now, it's not a problem because I want everything controlled individually. So I've got two foggers, which are ridiculous. I should have only bought the one because on 1% power, it fills up my room in about, well, to the point where I'm almost choking in about a minute. On 100% power, it takes about 15 seconds before I have to open a window. Slightly ridiculous. I've got a strobe light, which I can't currently test because I didn't realize that it pulls 15 amps. So I tested it once, turned it on, it went flash, turned it down, and it went flash again, and then the breaker went. So unsurprising there. I got two green lasers, one left, one right for this stages, on the stage. Two moving head wash lights. So they wash lights are designed to light a wide area with a particular color. And when I say moving head, I don't really all familiar with sort of lighting terminology, but moving head is essentially you've got a fixed base and then a light which can then rotate, and it's usually got two axes, which is pan and tilt up and down. So yeah, two of those for wash lights, four spotlights, which are again moving heads. All of these are color changing, and finally I've got these two RGB power buttons, which are big long sticks. It's kind of hard to show you without unplugging things. Yeah, big long stick of light. So yeah, so all of this is actually set up for my particular setup. You can load and save them. And yeah, so you can assign actions to any pad, or rather you would be able to if the interface is working. Under the hood you actually can. I've hard-coded some in. So for example, when I was pressing these buttons, they were actually triggering actions. They're not hard-coded. So yeah, they're triggering. The other thing is that, as I said, by default, nothing lights up. But as you can see when I hit this, the button lights up as I'm holding it down. That is actually also not hard-coded. That is an action. So all of the pads by default, in fact, all of the buttons by default, have an on action and an off action assigned, which is light the button up with its default color when you press it, unlight the button when you turn it off. The idea for the future, which I've not got to yet, but the idea for the future is that you can remove those or add those, or also add other things like, for example, if you add a what's the term? If you have an action on press, so like when you press the button down to light up the light, but then you remove the action to turn the light off when you let go, the light will just be permanently lit. You can then envision some other types of events, like for example, let's say you had a fixed time event, like you wanted to use one of the GIFs as a sorry, I'm getting slightly distracted by really flashy dead set stuff. There we go. Yeah, you can have some sort of timed action, like let's say you wanted to just display a particular GIF for one cycle and then go back to whatever GIF you were on before. You could quite easily have a scripted trigger for that, where you can hit the button, the light will come on. When you let go of the button, the light will not go off, but when the event finishes, it will turn that light back off. So you can tell that that is still running. And of course, you could also have that potentially so that if you continue to hold that down, it will cycle that event. Now, this doesn't just work for GIFs, it also works for the lighting. And one of the things that I'm going to do with this, which I think nobody has ever done before, is integrate Rocket with this. And just before I get onto that, I just want to show one final little feature because it's kind of cool. So if I slide the sliders up and down, you can see on the form that they follow that. So they work. It doesn't work is it doesn't know where the positions are when you first start. So you have to jiggle them around a bit just to get them to pick up the current positions. I'll probably find a way around that at some point. I'll probably work out how Ableton does it and then bypass that. I'll copy that. Sorry. Right. What was I talking about? Already got myself lost. Like what? 20 minutes in or something. I've already forgotten what I'm doing. Yeah, I genuinely got lost. Terrible. Somebody remind me what I was thinking about. Nope, can't remember. Rocket. That was it. Oh, there we go. Right, has exited. Right. So Rocket. The look. So sure. Terraces. We're probably just watching his stream. So Rocket is this. Got a picture of it. Awesome, but I bet there isn't one. There's also I think there is a version of Rocket called Ground Control. Yes. Ground Control is a C# implementation of Rocket. So you can. This is only the server side of it. So for those of you who are unfamiliar with Rocket, Rocket is essentially like a real-time variable editor. It's designed for syncing. Yeah, yeah, new Rocket is an intuitive way, a new way of whatever. It's a sync tracker. So you can synchronize music and visuals in demo scene productions. However, what I want to do is use it to actually script DMX lighting. So essentially, Rocket has this cool feature where you can say, expose this variable, and then it shows up in your code, and then you can, yeah, you expose that variable, and it shows up in the Rocket editor as like a column, and time goes down as like a tracker, like a music tracker, and then you can basically set those variable positions at particular times. It's a lot like animation and animation twinning if you've ever done that kind of stuff. But essentially, it's like live editing of particular variables. And of course, since DMX devices are just channels with variables, with variable values, mapping those across is not particularly hard. So the plan is that for a pre-recorded video set, so a sort of pre-recorded DJ set, you could go through and set all of that sync up so you've got all of the lighting perfectly synced up. The future plan after that is, because of course very few DJ sets, well you would hope, very few DJ sets are actually fully pre-recorded, and of course at demo scene events they're definitely not, because you know you see people like Luguber and Hoffman and Subi and whoever fell doing DJ sets, and they're all done live, so you can't exactly pre-record the lighting, particularly if you don't know their track list. So if you want to sort of live animate that, the best thing to do is essentially have the plan. In this particular case is to essentially have multiple Rocket sort of tracks for individual types of individual sort of lighting sequences. and then have those triggerable, but also have the speed at which they play back configurable, so that when a particular track is running, you can sort of just tap along to the track's beat, and it automatically beat synchronizes the lighting to that. And with some manual fine tweaking, so is also an option. So that's one of the plans. So hopefully that'll work and it'll be cool. It's sort of where I'm going. And I know I've just sort of rambled on for quite a while, but I will actually get to some code in a minute. So I think the best thing to do is just take you through what I've got so far. So the control form is the sort of main form. Helps if I've got the window switched back. So the control form is the sort of startup window. It's not ideal to do things this way, but I have kind of just plopped everything in the forms code and then move some things out into, obviously move some things out into classes, but most of the actual sort of like tied together, glued together functionality sits inside here, which is not ideal. It's probably like not best practices, but I don't really care. This is mostly just for me. I at some point I will be open sourcing this, but mostly this is just for me. So when the form starts, we've got a bunch of init stuff. So the init input is fairly simple. I can find it. There is also like a jump to thing, but I can never remember the go to implementation. This is how simple the init input is. It just creates this new APC mini class, which of course is slightly less simple. So this APC mini class basically describes an interface with the MIDI keypad. So you open up the same device twice, once as an input device, once as an output device. The input device takes all of like the key pressors and things like the positions of the sliders, and the output device is where you send note-on messages to light up the keypad. So it just essentially opens these, sets some event handlers, and starts receiving. So this then exposes some fairly like sensible functions rather than leaving you with low-level stuff. So this could be reused in other projects, really. But this sets the pad color. This I would definitely open source, probably before the rest of the code, because I know other people have wanted to interface these kinds of controllers, particularly this controller, because it's fairly cheap, with .NET projects. And of course, with it being a .NET project, you can host that whether you're writing in C#, F#, God forbid, VB.NET, but also anything else that can talk to the .NET runtime, so including C++ CIL projects. So yeah, you can set the pad colors, set button colors. Logically, I separate pads and buttons just simply for the fact that the colors that can be applied are different. It may turn out to be a pain in the arse later, but I'm sure I can work around it. So this is it. Input control messages. Input control change messages. Essentially, when the sliders go up or down. When the sliders go up or down, it basically calls this function, and it checks that the channel is correct, because everything only ever comes over channel 1. If anything comes over a different channel, I'm going to ignore it because that would be weird. And then it essentially just works out what the slider value is. Input note off again, and then just basically invokes the events. So it's basically just an event-driven thing, and then some cleanup. So the interface with it is actually fairly simple. The important part is knowing what all of this stuff does here. So the pad pictures and the button enumeration is what all the pads and the buttons map to in terms of note-on messages. And when you set a pad color or a button color, you send out a note-on message using exactly the same pitch value, which is useful because, of course, it'd be a pain in the arse if it wasn't. So essentially, when you get an incoming pitch value, you don't need to then do some weird translation to something else to go and send back another message. It's all just the same stuff. And I would be very confused if they'd done it any other way, which is good. So the next part of initialization is the display, which is fairly simple. The display is just another form. And it's just creating a new form on a new thread. The reason it's done on a new thread is because the GIF display on a loop can use up quite a lot of CPU time, and if you sit it on the same window thread as the control window, then the control window can become laggy, and particularly if you're using the control windows thread to handle the events from pressing the buttons on the MIDI controller, then of course if there's any lag with that, then you're causing a delay to changing lighting or whatever, and that's a bad idea, so that runs as a separate thread. Next. The button map. I'm not going to bother showing you the button map. The button map is basically just mapping the pads from the controller to the button controls on the screen, and then further to that, mapping them to any actions that are assigned to them. It's literally just like a loop that goes through and sorts all that out. It's no big deal. The action manager is kind of interesting. So the action manager handles when you press a button from the MIDI input. This is what maps it to those particular actions, like for example turning the light on there, or changing some DMX parameters, or switching to the next GIF or whatever. So if I just jump to the implementation of that. So the first thing this does, which this is not the best way of doing things, but if if there's a saved file on the disk which contains all of the existing actions, it loads that. The load and save functionality is just serialization, using binary serialization, which is amusing because my day job is security, and I know that that's really insecure because you can do horrible things to that, but I really can't bother to implement like some sort of custom load and save format. So, and again, with this only being me using it, who cares? So essentially, if there's no file, there's no sort of saved actions, what it does is it set up all the default. So here you can see the button action for when these are all the button actions. So remember the buttons are these ones down the bottom and these ones up the side, whereas the pads are obviously the pads on this. The button actions basically are default. You've got a down action and an up action, which is just turning the color on and off. And then for the pads, it's down and up and red and off because they're multicolor capable. And just for fun, the first pad is sort of, for the moment, just hard-coded. In fact, we've got a little to do in here. Remove hard-coded action. So, as you can see, assigning an action to probably just zoom in ever so slightly just so that you can see a little bit better. So assigning an action to a pad is fairly simple. Essentially, the pad actions, you add a new show GIF action to that, and that's interesting. Oh, of course, yes. So if the pad index is 0, so the first pad, it adds this pad action for that particular pad. So not only will it have the pad action to set the color when you press it down and when you lift it up, it will also have a pad action for excuse me, showing a GIF. So this just picks a particular GIF. I should probably actually make it so that there's another to do. So at the moment, this actually would set the GIF on both the press down and lift up. Normally you press it fast enough that doesn't matter. But I think, in fact, I need to put some sort of thing in the action definitions to say that when that certain types of actions are only done on press down, but not really worried about that for now. So yeah, this basically just loads up all the default actions. Action Manager refresh is actually quite important. This propagates certain properties within the action instances. It's kind of a technical detail, but essentially the each of the actions needs access to things like, so for example, in order for an action to perform something, like for example, go to the next GIF, or I don't know, change something in the DMX lighting. It needs access to those sort of the DMX objects and the interface to the display form. So this basically just goes through all of the actions and gives them access to those values, those objects, and then it saves the results, which is fine. So yeah, the Action Manager controller and display are just set here, which is fine. Possibly not fine. Might be a bug. I might have to fix that later, but so yeah, these are just init pads and init sliders and init buttons. Just literally create the form controls. So it's just taking a template button and then cloning it over and over and over again, and assigning it different parameters based on this particular index. So you've got an 8x8. Well, we've got two sets of buttons here, and then for the pads, you've got an 8x8 array, so 64 pads, which is quite a few. Initializing DMX. So the DMX Manager is quite similar to the MIDI Manager, or rather the whatever it is, the APC Mini object. In that it's essentially just a actually it's a bit more complicated. So in fact, it's worth looking at. So when the form opens, init DMX is called, and then init DMX creates the DMX Manager and then loads the config file if it exists, which is again very similar to what I did for all of the pad actions. The DMX Manager actually handles a lot more than just output. It manages all of the device instances that you've got set up. So you remember I showed that form with the DMX, with all of the DMX devices that you could add and configure and set the channels of and whatever. This is what actually handles that under the hood. So when that form saves all of its data, it pushes it out into this DMX Manager. So you can register devices with them. This actually works by reflection. So for each device type, so I mentioned I've got like maybe 5 or 6 different types of lighting and effects. Each one of those, let's say for example the strobe light or the fogger, has its own class which defines the DMX channels that it exposes and the properties that it exposes, and basically turns like usable properties into DMX data for sending that DMX data out. So what this does is it looks for all of those classes that are defined within the assembly. This is also designed so that I did it this way because in future I want to be able to separate those out into a separate library, so that essentially you can have plugins. So instead of having to recompile the entire thing, if I want to add or remove or modify a particular device type, or if somebody else wants to, all they have to do is write their own DMX device class, or rather it's called a target, so it's not there's an interface called IDMX target, which everything inherits. And yeah, essentially the DMX device has to implement those particular a certain minimum standard. And yeah, if somebody wants to write their own plugins, for example, to support new devices that I don't have, and they do have, then they can do that, and plugin support becomes quite easy. So when you want to add a particular piece of lighting, you pass it the type and then it checks whether it's a valid lighting type, which is fairly simple, and then creates an instance of that and then adds it to the devices. They can also have, in fact, it's probably one class, which is not that one. Device, here we go. So all DMX devices have a base channel. They have an advertised channel count. This comes in use when I'm doing unit testing. Well, testing at least. Essentially, I go through each of the defined types, ask them to give me their channel data, and then check that it's the same as the advertised channel count, which is just a quick check. A name, which you can basically name the object. So when you've got multiple instances of the same thing, let's say you've got a laser on your left and a laser on your right, you can say give one the name left and one the name right, and that way you can see the name of that in configuration. But more importantly, when it pushes the variables that you want to edit into Rocket, that's the name that gets used. So, well, or rather, that will be the name that gets used. I'm not quite there yet. And the full name includes the type name, which is returning the toString of the, which is just here. Basically, if the name is null, it just gives the type name. If the name is not null, it gives the type name followed by square brackets. I might change that around later. So yeah, just to give you an example of what a device might look like, a device definition might look like. This is an Equinox Vapor 1000. This is one of the foggers that I've got. Ones that I mentioned that are massively overkill, at least for this room. So you can see it's got a channel count, which is just 1. And it's just got a byte, which is just a Haze output. So 0 is, well, I think 0 is 1%, 255 is max. Actually, I think it's not even that, because I think they get mapped to 0 to 100%. So I don't remember exactly how it works, but basically, yeah, you're mapping it between minimum and maximum output. This is not one that I've tweaked around. So when I first wrote the device instances, the device classes, I just left everything as a byte. Some of them I've then gone through and converted them so that they expose things like, for example, one of the things that I want to do with this, and I might do it now just to demonstrate, is instead of giving like a byte with an ambiguous, it's just some technical data rather than like a useful scale. What I can do is I can convert this to a float and say, okay, the Haze output is going to be between 0 and 1. Now, of course, here it's expecting a byte as its output. So what I can do is go divide that by 255. Sorry, no, multiply that by 255. Try that one again. Assuming that this is between a 0 and a 1. And then clamp that between 0 and 255. And then, of course, this needs casting to a byte. So you can clamp that. In fact, how do I do this? Is math round of that. So yeah, so this essentially takes the Haze output from 0 to 1. So you can set it to 0, and it's not much fog out at all. You can set it to 1. I think 0 actually disables the fog output. And then you can scale that all the way up to 1, which would be maximum. This then gets multiplied by 255, so 1 would be 55. It's a byte. And then we just clamp that value and then byte. So that's the kind of thing that I've been doing with these since I got them. There's a better example, I think it's in this one. Yes. So you can see here that I'm using a uint16, and I mentioned before that there's only such thing as a byte for the actual DMX data. For the pan and tilt, and this particular device has 2-channel versions. So it's got a 9-channel version, which only uses a byte per pan and tilt, and then it's got a 14-channel version, which actually uses a 16-bit value for the pan and tilt. So what happens here is when you set these pan and tilt values, we do a little bit of bit shifting and masking to convert these out to the actual channel values that we want. So if you want more precise control over like the actual rotation and stuff, you can do that kind of thing. That's fun. Now, once we've got all of that data, we need to actually send it somewhere. And initially what I was doing was this, and you see that I wrote here that the serial DMX is crap, don't use it. So initially I was using just the Arduino and the DMX shield, and I was sending everything over the serial port. The problem is that serial, for a start, isn't packetized, not in any sensible way. So it's essentially a continuous stream of data that's coming through. It's packetized in terms of bytes, that's about it. So part of the problem there, of course, is that when you send data, you need to be synchronized, so that you know where the start of a packet and the end of the packet is, so you can actually interpret what that kind of data is. But also, you need to worry about like data throughput, because while technically UART over USB can go ludicrously fast, corruption is actually quite common, which is surprising, but it actually is quite common. You can send data and it just won't arrive at the other side, and for it'll arrive at the other side, or you just be mangled, or you'll be missing bytes and stuff if you try and push the data rate too high. So I think the most I got out of this was like I think it's like a 500 kilobaud or something, 400 kilobaud, and with that I had to turn the parity. I had to enable parity and set 2 stop bits, which meant it was even less efficient. It was just not keeping up. And part of the problem there is that you're actually sending quite a lot of data when you're doing DMX, because when you're doing real-time lighting, you particularly with movement or continuous color changes, you've got to sort of continuously set those values. And if you've got a lot of devices to control, then it becomes quite difficult in terms of data rate. So I started writing this, and I got a certain way through it, and I was having to do things like implement resets, so that when something went desynced, you could send a reset packet, which would then like reset the whole thing, and it would try to look for all these like frame ends. And of course, you've got to escape certain values if you want a frame end and a frame start. What happens if the data packet then contains a frame end or frame start byte? Because of course, DMX has got arbitrary values. So there's different ways you can encode that, but I was using escapes, and the code just grew and grew, and I was doing more and more work on the actual Arduino side. Just the performance was not what I wanted, and it wasn't very stable, and it wasn't very reliable. So then I thought, right, well, am I going to have to go back to Wi-Fi, which has its own problems? It's fine when you get it working. And working reliably, and it's fine as long as you're on a good network, which when I ran it on Nova, we were on a good network, and it wasn't so much of a problem once I ironed out some bugs and got everything set up. But it's more convenient to actually use Ethernet, so of course when I dug out that old Ethernet shield, that was quite nice. So then I wrote this network version of DMX. So it's a DMX target, which all the DMX target has to implement is send packet, which is just a bunch of bytes. And literally all this does is set up a UDP client so it can send data. It's got an IP and a port that it's sending it to. And then when you send a packet, all it does is just prepend the header byte to it and send it. And that's all it does. It's that simple. All you have to do, of course, is configure, basically configure the IP address in this, which I think fetch from a file. I don't even remember. Where is this used? What usages? Usages of network DMX were not found. Rubbish. Usages of network DMX were not found, then I would absolutely not have working software. Thank you, Visual Studio. Where is network? Oh. What? Now I'm very confused. Why is that not used anywhere? Why is that still working? That's not used anywhere. That is. Oh, I know why. Because I'm not creating it. Because I haven't turned it on. I commented out the code. It's in here somewhere. I don't remember where. Did I put that? Oh, I think it's in the DMX Manager. Used to be in here. So what I was doing before, which I think I deleted. Not good because I actually wanted that code. Typical. Also, I'm actually doing it in the DMX Manager. I'm not. Okay. So apparently I removed the code that I actually needed, which is dumb, and I don't know why I did that. But the code essentially was creating an instance of that type, that network DMX class, and passing it into. I'm going to fix that now because yeah, where's the DMX manager? The DMX manager is and oh, I know why I removed it. Okay, yeah. So at the moment, what's happening is I've got the DMX manager, which takes all of the devices. So this is a fairly important class here. In fact, sorry, important method here, which basically goes through all of the devices that are registered, looks at all of the variables that these devices expose. So, for example, for that, for example, the pan, the tilt, the master dimmer, red level, green level, white level, etc. For a particular device. It then looks at all of the properties that are. Well, it basically asks that device to give it its channel data, which is basically take all of that, take all of those properties, convert them into the actual raw bytes that you need to send as a DMX frame to a particular device to change all those colors and blah blah blah. It takes all of that data, turns it into device data, and then computes what would be the full channel data. So let's say, for example, you've got 100 lights, or 100 lights. Instead of sending every tick, you send 100 different lights worth of data. Particularly, like, for example, actually, this is a poor example. Let's say we got this what is it? This is a moving head wash. Let's say that you're changing the color, but you're not moving the head around. It's just stuck in its normal position. You know, you've moved it to a place, and then you've not changed anything. Instead of sending the pan and tilt data again, which is pointless because you're already at that position. What this does is it works out since the last tick which of the channels have changed, and then change it, and then works out what needs to be sent based on that, and then only sends any values that have changed, and just keeps track of that. So the idea there being obviously that you can minimize the traffic that was going through. That optimization I actually wrote when I was using the serial method because I was trying to get data size way down because it just literally wasn't working at all. But now this is actually really quite good. I'm quite happy with this. Yeah, the method that we're using now is nice and fast. There is a thing here, split threshold. This used to be, again, this is an artifact of the old serial thing. What this does is it splits every time you get 3 new bytes into the stream. It sends that out as a new packet. I can then bump that up later, so that if you remember earlier, I was talking about sending multiple frames per UDP packet. I can change that split threshold up to say 30, so that every 10 channel data, 10 instances of channel data, it will send a packet, and then of course any remainder at the end. It's just basically how many packets you split that up into. I could change that now, but I won't because I'll do that. It's not that interesting, and I can't really display it at the moment because of the glue code being missing. So yeah, this takes all of that data out and turns it into DMX packets. Now, the glue code that I had was essentially just taking the output of this, which is just a list of byte arrays, each of which is a packet to be sent. Then got pumped into the DMX target, which, as I say, just implements send packet. So the DMX target is network DMX. So there's a send packet. So for each of those outputs of that the DMX manager generates per tick, we then call send packet, and that gets sent over the network. That's all the glue code was really doing, except I was hard coding a bunch of other stuff in there just to test it out. So I had like lights moving around and things like that. I have the setup still on the floor, but I won't show you because it's basically just a rat's nest of wires and mess down there. Yeah, so that's what that's what's sort of where the state words. It's really hard. I think. There we go. That's sort of the state of play. I think I've actually gone through everything. Oh, apart from the actions. This is what a next GIF action looks like. So they're serializable because when you configure all the actions, it has to save them to a file, and it saves them binary serialization. Which again, terrible idea. Don't do it unless you know what you're doing and can implement things like serialization binders. This is if you're ever in a situation where a bad guy can mess with that sort of binary serialized data, because if they can create arbitrary types inside your type instances inside your application, which is a terrible idea because they all have, well, some of them have side effects, like being able to arbitrarily delete any file. Terrible idea. Don't ever send .NET binary serialized data over the network because it's a dumb idea. But this is just on disk locally. So yeah, these can all be saved to disk. And yeah, the parent mapping here says which action mapping. So an action mapping, which is also serializable, ties a pad or a button to a particular set of actions. So if you remember before when I was talking about actions for on press and on release, this is what essentially maps those into a particular set of actions. So yeah, you've got a list of actions here which can be accessed, and then a control type which is either pad or button, and an index which is for pads 0 to 63. For buttons, it's I think it's 0 to 17, 16, 0 to 16 because there's 17 buttons. You've got 8 along the bottom, 8 along the side, and then a shift button which is doesn't have a light on it, but you can still send it like commands. It just doesn't do anything. So yeah, so that's how the action mapping works. So the action manager then manages all of that. If you remember, I was talking about sending refresh refresh calls. This is another one where a refresh call actually goes through and sets this parent mapping and things like that. If you look inside of mapping, actually, where were we? You can see that the parent manager is on there. So that's another thing that happens when the action manager refresh is called. It sets the manager for each action mapping, and then for each action, it sets the parent action mapping, which is complicated, but basically that's how an action gets access to things like the DMX devices and things like that, and being able to change a GIF. So you can see here when perform action is called on this next GIF action, it looks up the parent mapping for this action, and then the manager that's attached to that parent mapping, and then the display, which is obviously the thing that's showing all those animated GIFs, and then calls next GIF on that. And then of course, where's the set button color action? You can see we've got this. It's very similar again. When perform the action, it checks the parent mapping, gets the manager, the controller out of that manager. So the controller is the class which describes the MIDI interface, and then sets the button color on that, which is cool. That was, yeah, there's a bunch of stuff in there. So yeah, but yeah, you can also limit an action to a particular control type. So if you don't want an action to apply to be able to be applied to, let's say for example, the buttons at the bottom, or to the pads that have to be like button only, then of course that's a way you can limit it, which is fun. So, what have I been talking? Holy crap! I've been talking about this for 1.2 hours. That's a terrible, terrible thing. Why am I doing that? I should actually write some code. Because all I've been doing is talking, which is not really getting us very far. Right. So, one of the things I want to do today is so the device manager form works fine, but the action manager form doesn't work at all yet. The only thing that this does is change the window title based on the control index and the control type. So it can be like pad 3 or button 3 or whatever. So importantly, I want to be able to save those controls. So control index and whoops. Control type. I apologise that my keyboard is super clappy. I did try and play around with OBS's audio filtering stuff, and it just, yeah, the keyboard's too loud. It doesn't know what to do with it. The action manager form, what does that actually need to do? Well, it needs to map controls to actions. So I'll just run this again just to remind you of how this works. So when you right click on a pad, you can say assign actions, and it pops up and says actions for pad 0. Again, apologies, it's really tiny and you can't see that. But yeah, the idea is then you can assign particular actions that are associated with that pad. So here, of course, what we want to do is control type equals control type and control index equals index. So this just, oops, I set that as linked. Yeah, I'm not worried about that. In fact, only because they're only ever going to be set in the constructor. So what I need here is an interface that's going to allow us to set particular actions for things. I actually quite like the way that the device works in terms of that. So I'm going to basically create something very similar. In fact, I'm even going to tile that one that way so I can see what that looks like. It's not quite the same because the I don't think we have that many keys for an action, do we? We will want action for an action. I can almost literally just clone this entire device manager form, gut out the existing code, and then yeah, I'm going to do that because that's going to save me a lot of time. Yeah, let's do that. Seems like a better idea. So I think I can actually just. No, I won't do that. I will rename my existing action manager form because it does need doing. Whoops, let's not rename it like that. Not rename it like that. That was not a good idea. Sorry, I put a plus in the name of it. Dumb idea. Name it to old action manager form. because it will in fact be the old Action Manager form. So then what I can do is I can take the Device Manager form and copy paste it. And I will just basically gut it and then right. And of course it won't open because everything is broken. So this is now going to be called, I'll just change everything that says Device Manager form. Oh God, I can't type. Over to Action Manager form. In this current document. What's the 5? So this is no longer a Device Manager form, it's now an Action Manager form. Why does that not want to... What? Oh, I know why. Because, of course, if I get that in here, not a partial class it, because it's something that's called Device Manager form. So again, let's do the same thing. Let's read. Hopefully, yeah, that's fine. Let's, yeah, so that's now called the old Action Manager form. That's fine. Okay, so we don't want to back so you can see it better. But no, I will leave it here, so that way you've got the interface in there. The Device Manager, what we do need, take this out here, we do need these two properties, which is fine. And we do need this code here, which happens constructor, which also DMX Manager. We don't have that. I'm just going to say it was null here because I'm not actually going to use this. I'll put it out in a moment. So this is the old Action Manager that can go away. The Action Manager form, and here's the code. Okay. So of course, this now currently looks like a Device Manager. It is not. One thing I didn't change was in the old Action Manager form. We had some special text in the title, which basically was a formatting hint. So in this, I'm going to basically pop the same in. Yeah, this is for the Action Manager, so it's actions for whatever button. This does. Okay, so we're just going to gut all of this out. So we're not going to fill the device type list, and we're not going to fill the device list because there aren't any devices. We're going to actually completely remove both of these functions. Yeah. Validate channels. This is the thing that checks for like overlap. Again, don't care. What else? This can go because can it go? No, it can't go. But we are going to remove that. And again, this is not going to go because we're going to repurpose this. That go because we're going to repurpose that. Actually, no. You know what? Yeah. Okay. So validate channels can go. Fill device list. I'm actually just going to create a new function called that. Now I'm going to change the name of it because it's faster. So private void device list. Fill device list. Okay, and now I'm going to rename it to fill action list. That means I can just implement it in there, and all the other references to it, like we would expect, are going to be there. So this is the DMX Manager. So in here we want to remove action to add action. Don't know whether we're doing any validation on this, so I think that can go away, which also means that that can go away, and the DMX Manager can go away. Yeah, to do so I put a question mark there because I'm not entirely sure whether I want loading and saving of actions here. In fact, I definitely don't because yeah, in fact, I'm just going to completely delete that because the saving and loading of all the actions is done globally, and I don't really care about. And that's of course caused problems because I removed the event handlers. What I really should have done is leave them in, get rid of that, go back here, and just delete the buttons and delete open file and save file from here. And now I can just delete these events because they don't do anything. Yeah, I think that actually is everything. Yes. So some of these need to change because this is obviously not a device list. This is an action list. So it's just been renamed. Again, this is device properties, which I'm going to change to action properties. And of course, we're going to want something on there, so we'll call that action properties click. Yeah. Then device properties, blah blah blah, device list. Okay, this is device list again. So action list. Let's call device. Action list. Cool. Device properties again. What's these? Action properties. Cool. I think best way to check is just Control F. Device. Oh. Ha. Like this. Good. Right. Okay. That means I'm done for that. Okay. So this actions list, how works? Ish. Oh no, I called that wrong as well. Action types. Not used anyway. Really? Oh, of course. So yeah, I changed. Remove the code for that. Add button, remove button. That's fine. Okay. We don't need we actually don't need the validity report, so that's going to go. It also means that the layout container is the wrong size. That's fine. Fix that. Just change the here's the layout container so that the size is what's the size? Space distance. If I change that to like what 700. Oh, and of course that's going to break because we actually yeah. Split distance should be, let's call it what 6 T. Oh, 700. 730. Oh no, 710. Yeah, that's close enough. And then perfect. Right. So what this action manager form actually needs to do is needs to manage actions. So one of the things it's going to need to do that is access to the action manager. So private read only, because again this is just taking to it action manager. Manager, I think I'm just going to call that. And of course, this also needs then to be passed the action manager. Ooh. Actually, yeah, I am going to need this action manager because it would be rude not to. I don't know what I'm talking about. Oh, that was dumb. Unless, why have I just done that? I'm an idiot. There we go. There we go. Right. Now this is going to complain because the Action Manager is less accessible than the Action Manager form because Action Manager forms are public by default, which means that actually I need to either make this, maybe it's private because no particular reason not to. No, let's undo that and then I can set it in here because the I have literally never used this feature before, but I know it exists. Somewhere in here is the word public. Why can I not see the word public? There's somewhere. I wrote control instead of control. Okay. Probably somewhere. I did write control type. Control type. Thank you. Thanks, Mad Moose. I am indeed blind. Okay, yeah, so I know for a fact that somewhere there is an option to cause the entire form to, instead of the term is, so instead of being a public class, you can make it like private or protected. It is in here. It's absolutely in here somewhere. I know it is because I've seen it before. Either that or it's only for controls and not for not actually form. Weird. Wouldn't think rotation would exist. Huh. Okay. I pretend. Okay. Apparently it isn't in the designer. It's impossible in the designer. But anyway, I'm just gonna make the whole thing private because it is only going to be used internally. And then of course I need to go in designer and partial. Not a valid class. Not a valid protection. Why? Elements defined in a namespace cannot be explicitly declared as private, protected, or internal. What? Okay. Really? Okay, well that's annoying. I didn't think that was a limitation. Fun. Okay. So it looks like I've got to make the action manager public. Which probably means I'm going to have to make everything else public. Yes, because the APC menu. Oh, this is really irritating. Oh god, it's going to take me. It's going to like want everything to be public now, isn't it? Jesus. Um, yeah, and then it's going to complain that all of these things are not public. Jesus. Ah, here we go. Everything's public. Guys, let me guess. Manning is. I don't really care. I'm just gonna make everything public. Full event type. Let's go to that definition. Then make it public. Right, everything's public today. Oh, and this is gonna get silly now, isn't it? Let's go to that. And let's go to the definition. Oh, okay. Definition of that. Oh, it's public. Load it again. Fine. Still succeeded. Excellent. Right. Okay. That was annoying, but never mind. Okay, so we're setting the action manager, which is useful. And we're setting all of these controls up. So the first thing we really need to do is fill the action list. So the action manager will give us a number of mappings. So these mappings are, it's just a list of action mappings. So we can filter these down. So if we say where, well, I'll just call it M for shortness. M dot control type equals equal control type that we've got, and M dot index is to the control index. And I'm just going to fill this so that we can see this. Okay. So so this will get all of the actions for this particular. So remember, this form is only controlling the action mappings for one particular button at once. So this is looking for all of the action mappings for that button. So then for each action mapping and in mapping in mappings, and then what we can do there is sweaty. I hate wearing headphones for this long. So go back to in the manager form. What we want to do is fill this action list on the left with existing actions. So actions list. Is it called actions list? What is that? Oh, it's called the action list. Action list.items.add mapping. Now, at the moment, this will probably just display the word action mapping for every single one. But what we can do is under mapping, we can override the toString on this so that it displays something even more useful. Either that or give it a property. Yeah, give it a property, which will then describe. Question actually. Yeah, which will then describe what the action does. Remember the action mapping. It actually has doesn't add. So I actually thought that it had separate actions for up and down. can press the button and release the button, but it clearly doesn't. And I think the reason for that is not under iPress map, iPress action. Oh, it is. Interesting. Oh, of course, yes, it can't be in here because then you'd need to. Yeah, okay, that makes more sense. So it's the actions themselves that implement the filter, whether it's up or down. That's cool. That's interesting. Oh. Oh yeah, no, that makes sense. Okay, so actually, there should only be one of these. So instead of where, I'm going to change this to a first. I'm getting confused about how this all fits together. So the mapping object for form, this should be actually for action, I press action, action in mapping dot actions. Here we go. So for each action inside the mapping, sorry, it's been a few days since I played with this. For each action inside the mapping, for that particular button, we want to add these items to the action. And it's the actual mapping itself. Sorry, action. And it's the action itself which needs to implement how it appears. So I think the best way to end that. So I think I'm going to do very similarly to what I did with the DMX devices, where on the DMX devices there's a base DMX device here, which exposed a name field. I think I'm going to do something similar here. Yeah, I think I'm going to do the same kind of thing. Did I implement that in... Okay, I didn't have an interface for that. That's interesting. No, I'm going to use a this one because it makes more sense. String name get set. Now, this also now means that my very few actions that exist are failing because I don't want a name. Yeah, they don't have names on them. Okay, so of course, yeah. So here it's saying, "Oh dear, it's not working." So let's implement that, and there we go. It's got a name, and of course, show a GIF. That's also going to fail. So let's implementing member there. The name is serialized, so that's good. We do want that, and also set pad color action also wants this method as well, and also set button. I think then completes. What do you think more about your interfaces before you start building lots of classes that connected to an interface that you then later change? Because then you want to definitely implement everything, which is a good thing, but it's also annoying. It makes more sense to think about it ahead of time. So, what this is going to display is going to display the name of the action type. Then it's going to display the name of the action type and then the actual name associated with it. Now, I was able to do that in a base class before because I wasn't using the interface. I was using an abstract class. Sorry, not that one. That one. So an abstract class can have functionality in it, whereas an interface can't. So I press action. iPress action can't have any implemented functionality in it. It can only expose the name, which is a bit frustrating here because I definitely want to use an interface. Don't want to use a base class. Not really, anyway. So, way around that is to actually. That's frustrating. It means I can't use a binder there. It's fine. No, it's fine. I'll just use the name. So the bind parameter for this, I'm going to change. Was I using binding before? I was just using toString. I was just using toString. Whereas with this, I can use binding. So display member. Here we go. So the display member, I'm just going to call name. Again, sorry that this is absolutely tiny. The data source I will set on fly. Actually, yeah, no, that works because the actions that are in there get automatically filled out. So where am I calling full action list? Add button. So when the form loads, I'm going to call the action list. Now, hopefully, it should work. Oh, of course, it's loading the old form. It's dumb. Old form. No, we've got a context menu strip, which I then go to the items in that. Has an options menu item, options menu item. Where it is, let's go to the event. Oh, it doesn't have a click event. Wait, what? Yes, it does. Oh, that's why. Here we go. Assign action menu. That's not the options. Assign action menu. Here we go. And then on the events, we've got this. Yeah, it's creating the old action manager form, which no, you're not. And this then needs the action manager, which I can provide. There we go. So that's that fixed. Oh, of course, yeah, we can know the options. There we go. So it's not actually. Oh, it is working. So instead of actually, it's got items in there that they're blank. So that's done. So we can see here that on the event type down, it sets the color red. On the event type up, it sets the color off, and this is the. It's not showing the names here, but this is the play GIF action. That actually sets the current GIF that's playing. So if I were to hit that one now, yeah, it starts playing that particular GIF, which you can't see, but well, I could move the screen over, but it's fine. We've already seen that working. So why isn't that showing up in the? That's annoying. Why isn't that working? So we're adding the action. I think it's looking for a toString in there, but the problem is I don't want to have to implement a base class for all of them. That would be really frustrating because then it would completely eliminate the. No, I suppose it wouldn't, because I could use multiple inheritance. Yeah, I'm going to do that because why the hell not? action-base.cs. I'm going to call this an abstract public abstract class action base public. Oh, no, this isn't abstract, is it? Or is it? Is it? I don't remember. There we go. So I'm overriding toString here, so I don't care about that. And this implements action. I press action. Here we go. And of course it's complete. Which now means this is stupid. This is partly why I didn't want to do this, but never mind. Screw it. We've got a base class. This is abstract, so it doesn't matter how I do this. Like perform action, because there's nothing implemented in there, so it will throw a not implemented exception because the action base can't ever exist. I wonder if you can declare that abstract and then not set. Oh, that's amazing. So if you don't want to implement perform action, and just make that abstract again. That's cool. Didn't know you could do that. Sweet. You learn something new every day. Okay, so what this is going to do is it's going to return it's going to return so I'm going to use a so if you're not familiar with like this new feature of C#, it has this really cool string interpolation thing, so you don't have to have a million string.format calls. You can just directly reference variables, which is awesome. But you can also do like maths inside it. So if I had a variable called x, I could say x is, and then show x like that. But if I want to say x plus 1 is something, I can say x is x plus 1. And you can pretty much put any .NET code inside of that within reason. I think it's just like a single statement that can go in there. And one of the cool things is that you can do things like array access. You can do things like I don't think can you call a method in it? I don't know. Oh god, not that. Base dot string. Does that work? Oh, you can call a method in it. Awesome. Didn't know you could do that. So again, I'm learning things too. But in this case, all I want to do is say I'm going to return this dot get type dot name. So the type name of the particular action. And in square brackets, I'm going to say whether it's an up or a down. So event type dot. I think we can just put event type because it's either down or up. And then how am I going to? I think I might just close this in speech marks and say name. Actually, I don't know if I want to do that last bit because that looks ugly. String name part equals name. Yeah, okay, so that's what I'll do. Oh, hang on. So that would be string.empty wrap. Oh, that's much better. And then name part. Whoops. Part there, and I'm spacing. Yeah. Not that it really matters. So what this does is, if the name isn't set, in fact, I'm going to change that around because it should be string.isNull or empty. because empty string is just as bad for me in this case. So what this will do is it will check whether the name is null or empty. If it is, it won't bother adding the name part on the end. If there is a name, it'll enclose it in speech marks and drop it in, which is just, you know, nice formatting really. So now that I've got action base, I now need to go through to each of my actions. So like, let's change this so it's no longer iPress action. Oh, the other thing I should do is change the action base to serializable as well, because that now contains an actual field that is serializing. And in fact, I then also need to remove. Sorry, I need to move these into here, and also move. Yeah, that's annoying. Okay. Private action mapping parent mapping. So you can't. What I don't want serialized is the parent action mapping. There's no reason for that to exist. Because otherwise you end up with like weird serialization loops and reference loops and stuff, and it's really stupid. So I don't actually know that that's the case, but I don't see the point of doing it. Whereas I can update that anyway later. But part of it is you can't set a property. Can't set non-serialized on a property. It has to be on a field. So instead, what I can do is return parent mapping. Whoops, limit mapping, and set can do parent mapping. So instead of an auto property, it's now actually implementing like a proper property. There we go. So yeah, instead of an auto property, we've actually got a real property in there now, which is what all of the other types actually do. So instead of setting that to iPress action, I'm going to set that to action base, and implement that abstract class. Yeah, okay. It is frustrating because by including the abstract void in here. Oh no, okay. So it does just force. Yeah, that's fine. Sorry, I was thinking that it was going to cause problems where inheriting type would not implement the perform action and cause problems. But then I remembered that because it's abstract, you have to. So that's fine. Cool. Event type and action mapping will, yeah, so we're going to kill that because we don't need it. We're going to get rid of all that because we don't need that. We're going to get rid of that because we don't need that. That because we don't need that, which is awesome. Which means the only things in here are actually related to the proper type, which is great. Now, part of the problem is that abstract action base control event control. You can do that. Also not that. Yeah, you can't have an abstract. Never mind, that's fine. It just means that the have to always take that as a parameter, which is annoying, but not terrible. Oh, okay. So we're no longer accessing that publicly that way, privately. Cool. So that works for this particular one. Now we're going to do the same for the rest of them. Get rid of that. Get rid of all of this again. Name is already declared because just change that to action base. Change that to an override void because we're overriding perform action. And also the event type and name need to go. So that means that each of these individual classes is much cleaner, which is good. It just requires a bit of rejigging of everything, which, you know, it's not terrible, but I did leave that in. Right. So let's change that again to action base. We don't need parent mapping, we don't need the name, we don't need the event type. This does mean that we don't have to define quite as much in each, much cleaner. Oh, great. Now, you can see that I'm explicitly setting an APC button from an index here, and because of course indices can be either for buttons or pads. That might seem weird, but this control type limitation annotation stops that from being a problem, because essentially the manager just rejects or won't even show the implementation. They won't show the option in the form to add this type to a pad rather than a button, which is fine. Again, save some messing about. And if action is the only one that's left now, so we'll just change that to an action base again. The parent mapping, don't need this, don't need that. In fact, the only thing in this one is that. In fact, this one was also using parent mapping already, which is the right way of doing things. And that's just rather silly. And if I build, fingers crossed, and it builds. Excellent. Now let's see if it actually works. Because, I mean, we can always say it builds, ship it, but it's not ideal. Okay, it doesn't actually work. Why is that not work? Okay, so this needs some debugging. So in the action manager form, we definitely add the actions. And I think what's happening is the... Oh, I know what's happening. No, I don't. Why is that not working? Should be that it's trying to the toString the... Oh, I know why. It is working. It's just that there's no name attribute. There's no value in the name of each of them because I haven't set the name. So each of these has a name. I haven't set it. So if I set this to Bob, and now it shows up. Like, so what's working or not? I've just changed all of that. Ah, never mind. There we go. There we go. We've got Bob, Dave, and Gary. Time is it? So like 11 o'clock. So that's probably why I'm doing silly things. Okay. So I know why that is. It's because I set the so in .NET, a lot of the controls like this have binding options, so that when you add an object to the collection that exists inside them, instead of just basically giving it a string, you actually give it the whole object. So you say, I would like to add this object to the list. And that way, when you want to go to like the selected item for the list, you can actually pull out that object and get all of its properties out of it, and all its fields and all its methods. And normally, what that would do is it would call the toString. In order to display something on the screen, it would call toString. Now, you don't always want that. You might want a particular property of that object used as, for displaying instead. So the controls have a thing called display member. And I set the display member to name, and of course the name is blank for all of them. So I'm a moron. Wonderful. Right. Okay. So now I've removed that. Should. Well, very silly if it didn't. It should. There we go. So now instead it shows set pad color action, open brackets, down, Bob. Set pad color action, open brackets, down, Dave. And then, I don't know what I call them, Bob, Dave, and Gary. I've got no idea why I've done that. What I should have called them is light on. Huh. Why are both of those sets down? Should be up. I don't know why that's not set correctly. Maybe I edited it and then it saved it. And then I'll change this to play dead set 3.gif. Okay. This has actually updated all the objects. Oh, this has actually saved them though. Well, I don't know why it's got two ups on that one. Maybe it will save it. Let's find out. Yeah, of course it saved it because it changed to Bob. Yeah, okay. So this still works, I think. Yeah, press it. Yeah, cool. That still works. So again, after editing those, see that when I press this, it's red. I can actually change that just as a demo. So if I change the color on the light on to green, good now. Hey, see? Now that's green. Cool. And you can also change to like green flashing. Oh, wow, I'll show you yellow just because then you've seen all the colours. Ooh, look at the yellow. Isn't that posh? No. But you can also change it to automatic flashing, so that if I click and hold it, oops, was I doing the right one? It will flash automatically. It's cool. So yeah, so that's a nice little proof of concept. That works. So there we go, green. Was I doing green? I think I was doing red before. Yeah, they're all red by default. Okay, these aren't actually assigned to anything. That's interesting. Okay, well, that's cool. That works. That is odd though, because I would have thought that the other buttons were set up by the automatic stuff. So when I was setting up the Action Manager, and if the Action Manager didn't contain any, oh no, it wasn't in there. It was in the control form. It was under initializing the actions. Here we go. So for each of the buttons, it should actually be adding. Very odd. But I don't suppose it particularly matters. What I will do is name equals, and I'll give each one of these a name by default, so that light on and name equals light. Oh, what am I doing? I don't know why I put that in front of it. For some reason I was thinking I needed to do string interpolation there, but I don't. And again, I'll do the same here. And name equals light on. So I'll leave this in here and just do the same thing. Name equals play dead set 3.gif. Now I don't know whether what's happened is I've somehow managed to screw up my save file. So these are the config files for the network DMX file. Just contains the IP address and port of where the hardware is to talk to DMX. And then we've got these TDC files. The TDC files are what I was talking about earlier when I was talking about binary serialization. So these contain the binary formatted dumps of all of the. Oh, that's a point. I think I know why that's not working. So that's because tam is the okay. So it's in the wrong folder anyway, but that's fine. This is writing everything. Oh, I know why this isn't working. Because I've changed all of the objects and it's trying to load a dodgy copy. So if I kill all of the control actions, I really shouldn't have permanently deleted that one, but never mind. Yeah, that'll do. If I run that again, that should redo all of the. No, if I just check that folder again, yeah. So you can see it's created all these control actions now. I think now if I press, yeah, okay. So now when I press these, for some reason the old save file got corrupted, but yeah, you can see that all of these are now lighting up. That one is also triggering that particular GIF. And we can now see that if we just go to, let's say, this pad, any pad in particular, it's got some default actions in there. So it's got light on and light off in each of those. So we've got somewhere. That's kind of cool. So we can turn the light on and turn the light off for all of them. And then, of course, this default action that we've set, which is playdead3.gif. This file name is here. And in case you're curious, this is just the folder with all the GIFs in. I've resized them mostly to like multiples of the frame size, so that for 1080p or 4K they sort of loop reasonably. I don't have any automatic resizing in. I did put some of that in, but oh my god, it's not very not very performant. So avoiding that. And also, you might wonder what happens when you try to set it. Actually, let's change this one. Might wonder what happens when you try and set this to like a file that doesn't exist. And if I've done it right, what will happen is, yes, it does this, which I feel like is appropriate, fairly appropriate anyway. Cool. So change that one back. It's because I don't want. Oh, yeah, it works again. So yeah, one of the other cool things is that because all of this is like live edited, anything that you change there is automatically set. So you can, as you're playing with the actions and as you're changing them around, oh wow, didn't like that. As you're playing with the actions and as you're messing around with them, you can actually just test them out as you're editing values, which is nice. Let's minimize that. Cool. So the next thing we want to get working here, we don't need that. Oh no, we don't need that. Action Manager, we don't need these. No, let's just close all of this and then just reopen the Action Manager. This code. Again. There we go. Move this across. So the next thing we really want to do is be able to add and remove actions. Remove is dead easy. So essentially, where are we? But yeah, if there's no action selected, then the remove button is disabled anyway. So to do remove action, so Action Manager, Action Manager dot do. It's just on the mappings. We can actually just remove the object that's currently selected. What I will do though is if action list dot selected item is not null, action list dot select item. Oh no, hang on. Yeah, see, this is confusing me already. So again, I'm not removing the mappings. I'm removing the action. Yes. So the current action, the current mapping, important than the so what I can actually do is target read only action mapping, and then instead of setting instead of doing this here, I'm going to do this here. That way, because we know that there's only ever going to be one mapping for that. Fact, what I'm going to do is say if there isn't a mapping, we should create one. So action manager mappings dot add new action map. The control type will be control type. Index is the index. I'm going to just add like a new list of. Oh no, I know that's just by default null. So yeah, so just in case we ever get given a mapping that's null, this is just going to automatically add an empty one. Now keep in mind the empty one is not the same as the default one, because the default one contains things like the light on, light off, whereas the non-default, whereas this will just literally create a completely blank mapping, and you would have to configure all the other stuff yourself. But that's a sort of weird edge case, because by default the mapping the mappings are all set up so that all of the buttons automatically have mappings assigned to them. So it's just in case. It shouldn't ever really need to be called, but screw it. So what we really want is not that, but we mapping dot actions dot remove. Much better. Which still just of course, yes. So a selected item, whoops. So we should just be able to cast that directly to action. Oh, hang on. I press action. Yeah. So we cast the select items for press action because it just comes out as an object, because of course the list object, the list box doesn't know what types we have, what types we're using, and then removes that from the list, and then calls fill action list, which basically just refreshes everything. In fact, fill action list should also got to do action list dot items clear, because otherwise what will happen is every time you refill the action list, just continue to re-add the object. So it just clears them out and then re-adds them, which is fine. No big deal. The other cool thing we can then do is give you the ability to add actions. Now, the ability to add actions implies that we can actually pick them, which is what this top controller is for, the action types combo box. We can add all of those in, and in fact we did it with devices here. So in the device manager form, here we go. Fill the device type list. We can actually just so I was going to say we can very much just copy paste this, but then I realised that DMX Manager actually contains the thing that gets the defined device types. A brief chat about it earlier. Basically, it just looks for all of the types in the current assembly where is valid lighting type is true, which is just basically that. So what I'm going to do is I'm going to essentially just write the same thing, but for manager, I think. Yeah, it seems a sensible place to put it. Now, did I? No, I didn't. Okay, that's cool. What I should have done really with the DMX Manager one is It shouldn't really need to be part of the instance because you don't really need the instance for it. So if we choose that to static, I'm going to break some things initially. But, okay. No, that's fine. Type of. There we go. Ha! Don't get time. That's dumb. There we go. So yeah, these could just be static, and then that way it's going to fail in a minute to build, and we'll find exactly what. Here we go. So this is the only case where it actually calls that, and there's no reason for that to be calling the instance. What it really needs to be doing is calling a static function, because there's no reason for it to be an instance function. It should just be a static function. You don't need an instance of it to be able to work out what types are in your class. That seems odd. So I will do the same thing here. Public static enumerable type, I think it was. What we'll do actually is, oh, it was a list. I don't know why it's creating a list. Seems odd. Maybe there was a reason. Never mind. Oh yeah, of course, because I don't know. Strange. Doesn't really matter. It does kind of matter. I'll change that because there's no reason to. Doesn't really matter. Could actually just return types. And yeah, I don't know why I made it a list. That's weird. I'm actually gonna do that. Copy paste all that. In fact, I'm gonna steal the XML summary. So why not? Of action. So, get defined action types, which is basically going to go type of action manager. Now, if you remember before, I said about add-ons. So in here, of course, type of this type of DMX Manager returns this current DMX Manager type. And this looks for the assembly that that type is in, which would mean that it's actually only looking for types within this particular assembly, so within this like executable file or whatever. In future, I will change this around so that this is then also hooked into the add-on system so that it can pull in types that way, and this will do the same thing. So I'm going to change this because it is valid action type. Oh, right. Let's change that. Action type. Okay, so type of action manager. No, type of action base is assignable from the action type, and it can't be an interface, it can't be abstract, and it can't be a class. Sorry, it must be a class, which is fine. Get defined action types. So yeah, all of that seems to work. Let's just let's see what happens. And the build succeeded, so it didn't need to be a list, it could just be an enumerable. Excellent. So the next thing to do is very similar to the device manager form, device type, full device type list thing. I'm just going to basically again steal because why would you not? Action type list. And again, we're going to change this to action manager dot get different action types. Action managers. Oh wait, did I implement them in the action manager form? I did implement them in the action manager form because I'm a moron. There we go. Let's try that again. Yeah, that seems fine. Yeah, that's fine. Fine, okay. It's working now. So then again, action. Whoop. There we go. Boink. Cool. So one of the, of course, one of the benefits here is that what should I call this first before I start talking about the stuff? Cool. So one of the benefits of this is, of course, that the two forms look very, very alike. So it's a sort of intuitive thing. Now if I go to assign functions, cool. So you can see that they've got next GIF action. Well, you probably can't see that because it's minuscule, but next GIF action, set pad color action, set button color action, and show GIF action. So you can sort of add and remove. I'm not going to hit remove because I don't want to remove one. And also, add does nothing at the moment, which is fine, so I can make it do something now. I wanted to make sure that that was actually working. So, add function, of course, to do add function. So if, no, in fact, yeah, if, what am I doing this one? Because of course, it's also had an oh, this literally just adds it. Okay, it's not great because again, this doesn't check that you've got probably a bug, but I'm going to fix that now. If device properties dot. Okay, so it's using device properties on that one. That's interesting. I'm actually still going to check that. A selected object. So if that selected object is not null, then do it. Because there's no reason. Yeah. So I do the same thing in here because I'm using the action list selected item here, but that's actually a bad idea, and I see why they've done that here. So action properties dot selected object. The reason this is better is because if you click away from the action list to somewhere else, and then click remove somehow, because it should disable it, but if it doesn't, it'll just remove this, and it won't be like unpredictable in terms of what it will be. Oh, and again, move that into there because there's only reason to do that. So, and also the add button was also broken because it assumes that there's a selected item, which now it doesn't because I fixed it. So that's good. So let's do the same here. If action type combo box dot selected item is not null, then what we'll do, just do that. Okay. Weird. Mapping dot actions dot add. Now here's the cool bit. So in DMX Manager, we actually have add lighting and remove lighting. I should probably do an add event and remove event rather than having it directly doing this in the actions method. I'm surprised that that's interesting. So what I should really do here is this. So if you look at the actions mapping here, this is just returning the actions directly. Thing with the DMX Manager, what it actually does here is, yeah, it returns the devices as a read-only collection, which is what I should be doing here, because I shouldn't be allowing direct modification of this. So actions.as read-only is actually really important here because it stops other code accidentally like clobbering state, even though, oh yeah, read-only collection, I think is what this terms. Oh, it just returns an enumerable. That's fine. I can just do that. It's not a problem. Yeah. So of course this is now failing because I haven't implemented anything in Action Manager. Action Manager is where the add and remove should definitely be implemented, because that way, if there's any additional housekeeping that needs to be done, it can be done there, rather than me just implementing it every time I want to add and remove a device. Which, sorry, not a device. Add and remove an action, which is a dumb idea to do. So, for now, it's just going to be public void remove action. I action. Action. Okay. Could technically be an action base. What am I using here? I'm actually, the action manager shouldn't be doing this. It should be the action mapping doing this. The I action, yeah, that's more like action. It should be public void remove action. Press action. And then we can just do literally just action stop add action, because there's no housekeeping that currently needs to be done. I can do some additional stuff later, but DMX literally just called, yeah, add and so add action, press action, and action stop. I'm sure one of you is getting your hair up. Add action. Cool. So now we're adding and removing them inside here, which makes much more sense than actually doing it. There we go. Now, this is why, because this is not actually what should be. This is not the method that should be there. It should be type and then only if the action manager dot. Where's the point? So this wasn't so much of a problem in the DMX one, because this the add device and remove device were in the same. So you can see if even though this is static, it still calls OK. I should probably prefix it just because I know it's superfluous, but I prefer to do that on static calls to just show that it is a static call. Even though this one's private, sorry, because this is, it doesn't matter that this is private because it's happening inside of the same class. Whereas in this case, we're trying to call it in a different class, so we're going to have to make it public, which is not ideal, but it's not the first thing. Like, that you can check whether it is a valid action type outside of the class. But yeah. Action manager dot is valid action type action. So if not that, then we're going to throw an exception because I don't know why I called it in. I don't know why I put an invalid cast exception here, but it's close enough. It doesn't really matter. It just needs to throw an exception. Create new action instance invalid type, and then action. Yeah. So the other cool thing that's happening here is that we're using an activated create instance. So .NET has this really cool feature that you can just basically say, here's a type, create me an instance. And you can also for particular constructors and stuff, but in this particular case, I just want to create an instance of something, which is great because reflection is awesome. And of course, this needs to be then cast, so it's an I press action of that. So that's adding that in. Now, there's one additional restriction here. Because an action mapping goes to a particular control type, what we should also check is if it's running outside. Sorry, I got confused for a moment. So if the action type dot have custom, so the custom attributes assigned. So if you remember, set button color action and set pad color action have these control type limitation attributes assigned to them. They stop you from trying to set a pad, a button color to a pad or a pad color to a button. So what we want to check is that that's okay. So if we say custom attributes dot first, because there should only be one, ca dot attribute type equal is actually no, not is equals type of control type limitation attribute. So actually what we should really do is this. Limitation attribute equals. Now the other thing is it should be first or default because we want it to be null if there isn't a limitation attribute applied to it. Which is fine. So what this is saying is go through all the custom attributes applied to the type, and for the if it's a attribute type is if it's a control type limitation attribute, then add it to then set it to this. So if limitation attribute is not null, we now also need to check that the limitation is enforced. Right, I think I might change this to a bool, so we can return false if that's yeah. Otherwise return true. So if so, then this will return the limitation attribute object that's assigned to the type, which will then have the values inside it. So in fact, what I should have done is this, and then that. Oh, no, we didn't like that. Oh, of course, yes, okay. No, so what this is actually doing is just returning information about the custom attribute. So I'm going to actually rename that. Oh god, what we've done. Okay. Limitation attribute info. That can still be null if it doesn't exist. So then what I need to do is action type dot get custom attributes data, I think. Oh, actually, is that what I wanted? Using reflect. That's what I wanted. Not that. In fact, probably also do that. Because that way I only have to do the one call, and I don't have to do any filtering. And then that actually returns in the right type as well. I think just quickly check get custom attribute. Oh, should check the generic version. Okay. So a custom attribute that matches T or null if no such attribute is found. That's exactly what I wanted. Because that way, if it's just null, I can handle that as an error, and it's no biggie. Which is it. So there's it's not null. We actually start checking this. So the limitation attribute. Here we go. Then we can check the type. So if limitation attribute dot type is not equal to the control type, because of course we know what control type it is because we've just loaded the form and we were given that. So we can check that the type of button, so like the pad or whatever, is actually matching. So if it's not that, in fact we don't need the return false. So verify that if a control type limitation attribute is present, verify that the control type matches. So we can say false for some of it. Yeah, this is a sort of a bit of a stopgap because what should really happen is in the drop-down, it shouldn't even appear for this particular action type. In fact, yeah, what I should really do is under the action manager, I should be doing the checks here, really. But I'll probably do that off stream because I've just written this and I can't bother to change it for the moment. So I'm just going to put a to do in here. Move this to action manager dot get defined action type and is that action type. And we can filter on the drop down. Whoop, down. Cool. So that way I can just add a parameter into that and say get the defined action types for this particular button, rather than doing it here in the add action and then like failing out, which is a dumb way of doing it really. I shouldn't have done it this way, but never mind. So add action, and I think should we just pass the? Yeah, we do. So we just pass the selected item. Yeah, type. Type. Yeah. So if not that, show cannot add this action type to a blank, and I think it actually be $, because I'm going to say to a control. type. So the idea then can be that it will say invalid type. Message okay, and I'll do. Screw it. I don't care. I don't care about it. Yeah. Okay. So what should happen now is, oh, why did that show errors and then compile fine? That's weird. Huh. Very strange. Cool. So we can see that like now we've got the drop down with next GIF action and blah blah blah. That's all fine. So like if I wanted to, in fact, let's just change this. Assign action, and I'm going to pick a GIF. Any GIF. Let's go with I don't know. Go with let's go with the swag dance. No, not the swag dance because it's not the good version of it. Let's go with this really cool pixel recording GIF. Ah no, you know what it's got to be. It's got to be that one. Oops. So actions for pad 1. So we're going to add a new show GIF action. This. Oh, and we got an exception. Missing method exception on action type. Show GIF action has no parameterless constructor. You know why that is? Because okay, so let's just kill this. I know why that is. Because the action, so the show GIF action takes a file name, which I don't want it to do. So there's another thing that I should have in unit tests. So I should have a unit test to check that there is a constructorless parameter. Sorry, a parameterless constructorless parameter. Oh, in fact, what I should have done, there we go, is this. God's sake. And what I should have done is that. And that way I have both. So if I want to create it already. This should work now. So now if I want to set this second pad, have an action, which is show GIF action. There we go, that works now. And I want to set the file name to, well, not all of that. I want to set the file name to that. And the name is just going to be play. Do that. That's funny. Now, if I switch over to, oh god, switch over to that and hit the second pad, which is, it crashes. Amazing. So, why did that crash? A null reference exception. Because the parent mapping was set to null. Okay, that's why. So in the DMX Manager, when you add a new device, I believe that what happens is add lighting. What happens is you create an instance, but I think if I remember correctly, you also then have to call. No, you don't. That is interesting. Ah, yes, because in this case, the Action Manager has a a refresh function, which then automatically refreshes all of the values and stuff. The references to Action Manager and things like that. So what I should really do though, seems kind of like a dumb way of doing things. I'm not entirely sure why I did it that way. So what should really happen is when you do an add action, what should really happen is new action, whoops, equals that, and the new action gets the parent mapping, sets this, because then that way it's got an action mapping, and then just add the new action, which that should work without having to call refresh this time. Oh, and just to prove that I was not lying when when I said that the lift up, like when you let go, it needed to have an action called. That is now stuck on because of the program crashed. It'll fix itself in a moment. There we go. It's undone. So sign actions. So it didn't save the actions, which is good because that one was broken. So we're going to add that, and we're going to add and again, which was that one. I don't run it. Oops, no, that one. Oh, that's fine. Okay, this time, hopefully, this time, what happened is I'll press this, and yes, excellent. We get the blue running. Oh, I just realised. Sorry, I had the stream set to the wrong window for a minute. So there you go. I fixed the code, and it works. So we got poo brain. Sorry, I just realised that I just left that up for ages. So what we added there was just this basically. It changes the new action. Sorry, it assigns this to a new action and then sets the parent mapping before doing this. It should technically eliminate the need to do. No, I know why. So the reason for having the refresh call here is that when you load the mappings from disk, none of them are actually set. None of the action mapping parents are set, and none of the manager parents are set. So that just basically sets the thing up again because obviously you can't have you don't want to serialize the manager object. You don't want to serialize the action manager. So you just want to serialize all of the mappings and the actual actions and flush them to disk. So all of the references to action manager need updating again, and just to make sure it goes through and re-updates all of the actions parents to the correct action manager as well. Sorry, correct action mapping. So that now works. So we can set arbitrary things to functions, to buttons. So that's cool. So I can launch the poo brain GIF now from another button. So I'm quite happy with that. Now it's getting really late, so I am going to call it a day. So thank you to the one of you that is left here. I'm guessing that's Mad Moose. I'm guessing a lot of people are either gone to bed or are watching GDQ. I was warned that this is a terrible time to stream, but never mind. But yep, thank you for watching, and see you all next time.